Hi everyone, in this video let us understand the DevOps design criteria for Amazon EKS cluster. This typically includes the day-to operations and continuous cluster operations. The team can be called DevOps or platform or infra engineering teams. It depends from company to company. However, the list of activities includes creating the repo structure in the GitHub for the application code, the microservices deployment configuration files, and also infrastructure as code templates. All of this needs to be configured in the respective repos in the GitHub. And another decision we need to make is with respect to the ECR repos for storing the container images for all of these microservices. And then we also need to decide the right CI/CD pipeline and various stages in the pipeline. And we can use either AWS CI/CD tool or open source tools. And at the same time, we also need to decide the right application deployment models. For example, you can use the rolling update, blue, green, canary, and also the application packaging format. It can be Kubernetes manifest files, plain or customized scripts. Let's get started. Let us say we have an Amazon EKS cluster deployed in the cloud. First, we need to identify the right GitHub repo structure for hosting the application code for every microservice. It is recommended to keep a dedicated repo for every microservice so that the developers can push their changes and build and test it independent of other microservices. And at the same time, it's good to have a separate repo just for hosting the Kubernetes manifest file, the Helm charts, the customized files. Then one more repo only for hosting the infrastructure as code templates. This could be CloudFormation, Terraform, Crossplane, or any other tools. And also, we need to create the right ECR repo structure for hosting the container images. If you have multiple microservices for a given project, probably we can leverage the namespace feature inside ECR to club multiple repos together. And next, we need to decide the right stages in the CI/CD pipeline. For example, we can have code commit or GitHub for hosting the application code, then a code build stage for building the container images and pushing them to ECR, and then one more code build stage for deploying the applications into the cluster. Here we talk about a very simple pipeline. In general, you can have many more stages. For example, you can include stages for secret scanning, scanning the container images, or code scanning like SonarQube tools. And you can also have some stages where you deploy the application first in a staging cluster, do some testing like integration test, unit test, and then have a manual verification to deploy into the production cluster. We can also deploy at the same time into multiple clusters if we have different cluster environments. So another decision we need to make is whether we can use GitOps model. In this case, the source of truth lies in the GitHub, and the GitOps controller like Argo CD or Flux will be deployed in the cluster, which will sync the state of the cluster to the manifest in the GitHub. So let us summarize the DevOps design practices. First, let us identify the right repo structure for application code, Kubernetes manifest files, and infrastructure as code templates. Then choosing the right ECR repo structure for microservices for hosting the container images, and using the right toolchain for the CI/CD, and deciding the right stages within the pipeline, including various stages for scanning the code, scanning the images, manual approval, load test, and then deploy to the production. And choose the methodology such as GitOps. And also at the same time, it's important to decide the right infrastructure as code tools. It could be CloudFormation, CDK, which is Cloud Development Kit, or Terraform or Crossplane. And you can also decide the right application deployment models. You can use the rolling update, blue green, canary, and the DevOps team also normally keep a runbook of cluster upgrade instructions in terms of upgrading the control plane, data plane, core components, and any other additional controllers that you deployed in the cluster. And also have a strategy for the DR, whether you have active, active passive, active standby, DR patterns, depending upon the criticality of the business applications. And also you can decide on the right application deployment configuration files. It could be Kubernetes manifest file, Helm, or customize.